So we have seen a senior statesman, right? In the form of Sailesh. Now we have a budding, I would say, an engineer, right? Lahari has spent 1.5 years in the IT industry, and I think this is your third talk. Third talk in the meetup, and then she has also done a full-blown talk at PG Day. So let's encourage with a round of applause to Lahari. Thank you, folks. Good, please.
Thank you, everyone. Good afternoon. So my name is Lahari. I'm working as a software development engineer in testing at PGH. So today I'm going to talk about the air-gapped systems and how PGH is making use of these air-gapped systems for Postgres deployments. So many of you are aware about air-gapped systems, right? Water air-gapped systems. So what is an air-gapped network and what is the difference between air-gapped and non-air-gapped network? So you all know that no matter how hard our internet security is, how strong our internet security is, there is always a chance for cyber attacks. There is always a chance for ransomware or malware attacks. So for organizations, in order to secure their data or some of the applications, they go for air-gapped network. So which is completely isolated from the external networks or from the internet, which is completely isolated. So that is what we call as air-gapped network. In the picture, you can clearly see that in non-air-gapped, it is connected to the internet, and whereas in air-gapped, the computers are connected locally but not to the external network. So this is the definition here. It's just a simple definition which tells about the air gapping systems, and it states that with these air gap systems we can provide our data from the attacks, from the cyber attacks, data breaches, or whatever, and then so here we can see what are the features of air gapped systems. So the first feature you're talking about here is physical isolation. Since it is entirely offline and it is completely isolated, we can say that it is preventing the external cyber attacks, and we can see the strict data transfer controls, which means it is only the one-way communication. And also we can see that we have multi-factor authentication encryption. So you know about the firewalls, where it is a software which monitors the incoming and outgoing data with some predefined security measures. So it is one of the key feature. And authentication and authorization. So though it seems like it serves two different purposes, but we use it together. For example, if you go for authentication, it asks about our validation. Like you can see about the in Postgres, we can see about the OS user and super user. So super user has the privileges of managing the administrator level access, whereas for OS user there will be some restrictions. So here, and then authorization. So what will an authorized user can do? So this tells about the authorization and authentication. And for data encryption, see some of the apps are using the encrypted data. Like you can see, we have end-to-end encryption in WhatsApp. So it converts the plain text to ciphertext in encryption. So, and for decryption, it converts the ciphertext to plain text, which means this some of the binary data can be scrambled or some of the data can be masked for the security purpose. So for secure and offline environments, Postgres provides us the robust capabilities for for air-gapped systems. If we know about the scalability, which handles the large sets of data and growing workloads without any degradation in the performance. So it is one of the key features. And also it ensures the high availability, which ensures the data consistency by using the advanced replication strategies like asynchronous or synchronous replication. So, and then these are the features, whether it may be air-gapped or non-air-gapped environment, these are the features that one should, any Postgres, any database that it should satisfy these features. And then, so how PGH is making use of these air-gapped systems. So if you see here, whether the data may be at the disk level or while the data is transferring, it provides an end-to-end encryption. And it also provides an powerful CLI tools for exporting the data from the external network to the trusted internal network or a device, I can say. And it also have some failover and disaster recovery management with some of the extensions it is using, like I can say Spark extension. So Spark extension serves this failover and disaster recovery management and conflict resolution also. And with these features, it can be used in critical use cases, especially in defense, where the nation security is important. So in such cases, these air-gapped systems will come into picture. So PGH has an distributed architecture, and it is very, very famous for multi-master architecture. And so it also provides the strong security over the data encryption and very strong control over the data with you can say some security levels. Layers. I just sorry. So I am just going to show you the demo, like how the PGH is using this air-gapped networks via TARZZ, and also we can also upgrade some of the features with the help. And so here you can see that we can use this wget command, and we can download the PGH repository offline. And then after extracting it, you can start your local server in your local machine. And then you can, install your things. You can do the required things all there. I'll just show the demo.
So I've worked with Lahari on this project a bit, right? Why we are looking at air-gapped systems, some of the defense customers, some of the customers who does not want to expose their data sets or some of the systems to the outside internet. We are working with a couple of government agencies where security and the network go hand in hand. And you'd call these as multiple terminology, right? You would call them as air-gapped systems. You would call them as DMZs. Some of them called as non-network entities, right? So what PGH does is PGH, quite a few of you know, it's one of the budding startups which is working in the active replication and also on multi-master technologies. That's the, one of the niche areas what Postgres global ecosystem is not yet there, banging on the door saying, hey, we are multi-master compliant, we are active replication, quite a few other products are there in this ecosystem where Yugabyte is one, CockroachDB has one, Google does some stuff, AWS does some stuff. PGH also does a similar, which is the active replication. So how do you achieve active replication when you are working in an air-gapped environment is what we are going to be looking at. So essentially what we are saying is we are looking at a PG-Edge tarball which has the entire setup of those Postgres, Spock extension, all the extensions and the bells and whistles that you would need for an air-gapped system to be completely up and running. Make sure the high availability aspects, make sure the network security and the low latencies are all taken care.
And here you can see the list of the components that are installed here. So audit, backrest, citus, cron. So these are the different versions that we have, and we all can get that through this tarball. And so here, let me pause. Yeah. So now we just wanted to start your local server in the cache, and then you have to make a new directory, and then from there you can from using your local server you can set the PGH repo over there. So let me show that. And then you can use this curl command which installs the latest CLI version. So the latest CLI version now we are doing here is 24.10.8, and if you want to see the entire info, then you should just give the command pgh info, and here you can see the CLI version 24.10.8 and the using the local repo URL. And then what I am trying to do is here I am trying to make a cluster which creates 2 nodes. So for that I am using this cluster JSON template, and I am giving the cluster name as demo and the database user as LCDB, creating 2 nodes with password provided and the PG version as 16 and giving port number as 6432. And here you can go through the demo.json file. So what happens when we give the command cluster JSON template, it just creates an demo.json, it creates a JSON file with the cluster name, and in that JSON file you can see the JSON version, cluster name, and also the versions and the Spock version. Here you can see that you can, if you don't want to mention any version of Spock, if you give the empty string, it installs the default version of Spock also. And in node groups, you can see the number of nodes created with public IP, private. I am doing this on EC2 instance with public IP, private IP, and here you can see that I just got created 2 nodes, and then now I am trying to create an cluster with the command cluster init demo. So yeah, here. So it is trying to installing the PGH, setting up the PGH using the command line interface tools, and then here you can see the nodes created, and we got the node ID and also the subscriptions as well. Yeah. Here you can see that subs created here. And after this, what I'm doing is I'm just installing the Northwind database over here. So here you can see this. And then I am trying to run the Northwind by giving the database name, offset, rate, and time, and which gives you the information about. And also we can you can install Northwind using the repset. Here I use the repset default, and this is the reason, and that is the reason we are getting here as adding table Northwind to replication set default. So the replication sets are created in this cluster init command. And you can see this Northwind run, and the details are here. That's it. So any questions?
So when you say air gap system, so the data flows from one side to other side through logical replication. Is it?
Yes, it is through logical replication.
Okay. So what direction of replication?
Replication? No. The stream, it's not one, yeah.
Yeah, the architecture.
So essentially, the Spark extension, which is part and parcel of these air gap systems, are installed on all the machines which are part of it. So the air gap system that Lahari is trying to alleviate is the entire database communication, the entire cross-wiring of these cluster entities are all within those private isolations, network isolations. So there is multi-master replication happening between them. That mesh and topology is behind a complete air gap system. So I would say it's a combination of both having high availability and at the same time the cluster resiliency against all the intrusions and stuff. Right. Any other questions? So if you take a look at some of the components that PG Edge is a simple Postgres installation plus multi-master and active-active replication. If you take a look at it, it's the whole ball game, right? The 9 yards is all of installing Postgres, configuring Postgres. PGTune is also one of the extensions that gets loaded, right? It takes a look at what is the system configuration you have and configures your Postgres parameters, the configuration parameters. And then you would have also observed it has something called as PG backrest. So your backup and recovery is also embedded within the Postgres installation, right? That setup of the whole, setting up your cluster, setting up your backup and recovery, making sure the clusters are behind a network firewall, making sure the entire cluster is inside an air gap and isolated, right? That's the whole thing that's happening. Only one touch point that we have with the internet is when you are grabbing the tarball. That is the only touch point you have within the whole demo. That is the only touch point that Lahari had with internet, I would say. Anything else you want to add?
So the dartboard which you downloaded, is it works across all Linuxes? Is it portable binaries?
So we have got one ARM, we have got AMD. There are multiple DBs available, tarballs available for each and every operating system. The support is for Ubuntu's 22, Ubuntu 22, RHELs, Rocky, Debians. All of these are available at this point of time. So one question that I would ask is, if you are maintaining something of this sort, right? How would your upgrade strategy look like? How would your major version upgrade strategy look like?
That was going to be my question to you. How do you deal with upgrades?
Probably I was reading some of your minds when we are looking at it, right? So you have got one tarball, which says version 23, 24.10 dot some stuff, right? So by the way, the versioning is 24 stands for 2024, and then the next version is the month and the release that we have we had patched it. So essentially, what you would do is you will grab the latest and greatest of the tarball, and then make sure that local app server or the local web server you have got, you feed in all the latest and greatest, right? It's just bunch of C files and the binaries that we would have. So when PGH says, hey, PGH update, it goes ahead and grabs those latest and greatest files, and the repo makes sure that all the latest and greatest software is also part of that repository. So you bring about, say, PG update, say you have 17.2, which is the latest and greatest. You will see that 17.2, and then you can just say PGH upgrade, PG17, boom, you should be up and running on PG17 with the latest patch set 2. The whole gamut of things lies in how your local repository is being set. The local repository where you are going to be feeding those tarballs, the latest and greatest tarballs.
So one question here.
Yes, please.
Is it also tested against the Docker also?
Right now, our entire PGH cloud, which is the SaaS offering, is running on Dockers.
Okay.
Yeah.
So that is why it is showing nodes, is it?
Yes. So I mean, actually, Larry wanted to show how that upgrade functionality looked like, but in the midst of it, we stopped it, and that's the upgrade functionality, how it goes through. Any other questions? Let's put Lahari on the spot. We do, yes.
Why do you need like more security? It's already air gapped, right? What is the use of having additional encryption and other things? Because it's
We aren't introducing any additional encryption. So what we are saying is with PGH, it supports out-of-box air-gap system installation. That's it. We are not introducing any additional security measures per se. Yes, please.
PGH, is it fully compatible with the standard PG?
It is standard Postgres. It has got no other bells and whistles. It is standard Postgres. It is built on top of Postgres. So you could essentially pick up your PG16. Say, for example, you are running a PG16 or a 17. Grab the Spark from the Git repository, compile that guy, and then get that Spark extension installed on your database. You are a multi-master compliant at that point of time. Cool. Lahari is going through some anxious moments, so let's release her. And thank you so much for your time and sharing your knowledge.